Alright class, tonight I'm going to go over some factoring tips for you, or some factoring review. And the first problem we're going to look at is x squared minus 4x minus 21. And remember, usually these are set equal to 0 because our goal in factoring is to find out if we have some x-intercepts. So the first rule of factoring is to see if you have a GCF. So you want to ask yourself, is there any GCF between x squared, 4x, and 21? So other than this GCF of 1, we don't have a common factor. So remember, when my a is 1, we do the little puzzle thing where I make the x, and here we put a times c, which would be negative 21, and then we put our b here. So I want factors of 21 that's going to add to give me negative 4. So 21 has factors of 1 and 21, and 3 and 7. So I know I can get a 4 from here. I need to be a negative 21 to multiply. So one of these will be negative and a negative 4 when I add. So if I make the 7 negative and the 3 positive, these two multiply to give me negative 21 and add to be negative 4. So I would factor x minus 7, x plus 3 equals 0. And then if I want to multiply this back out, I get x times x is x squared, x times 3 is plus 3x, x minus 7x, and then negative 7 times plus 3 is negative 21. So this is x squared minus 4x minus 21. This matches my original equation, so I know that this is my correct factorization. So this is my answer here. Alright, our second example we're going to look at is 2x squared plus 13x plus 15. And this time I'm not going to set it equal to 0 because we're just going to factor. So remember, if we have set equal to 0, we want to solve for the factorization and get x values, but we're not going to do that on this problem. So again, the first question you asked is, do you have a GCF? And the easiest thing to do is look at your a value and see if your a value goes into the other b and c value. So I can tell you 2 does not factor into 13 or 15, so we do not have a GCF. So this is one of those cases where my a is not equal to 1. So this is where we want to take do the little slide thing. I'm going to take this and slide it down, and I'm going to multiply 2 and 15. And I'm going to take the 2 away from the x squared, and I'll wind up with x squared plus 13x plus 30. So now my a is 1, and I can do the puzzle thing. And I'm going to put a times c here, which is 30, and then put b here, 13. So I'm looking for factors of 30 that add to give me 13. So my factors of 30 are 1 and 30, 2 and 15, 3 and 10, and 5 and 6. Okay, well, I can get 30 if I multiply 2 and 15, and I can get 13 if I subtract 2 and 15. Well, I can get 30 if I multiply 3 and 10, and I can get 13 if I add 3 and 10. But the thing is, these all are positive. So if I subtracted 2 from 15 and get 30, I'm going to get a positive 13, but I'm going to get a negative 30. So I know that's not the answer. So my answer here is 3 and 10. So my factorization would be 3 and 10, because 3 times 10 gives me positive 30, and then 3 plus 10 is 13. So my factors come out to be x plus 3, and then x plus 10. Alright, so on this one I'm not done, because remember we had to slide the 2 down here to change the 15 to 30. So now, since I multiplied by 2, I'm really factoring out the 30 here, so I need to divide that 2 back out. So I'm going to divide this by 2 and this by 2, and then reduce my fractions. Okay, so I can't reduce this. 3 halves is going to stay the same, so this becomes x plus 5. So remember, when we can't reduce some fractions, we do the little whole bottoms up thing, and I move the 2x up there, so I get 2x plus 3 times x plus 5. Okay, so we're going to multiply this back out. 2x times x is 2x squared. 2x times 5 is positive 10x. 3 times x is plus 3x. And then 3 times 5 is 15. Add these up, and I get 2x squared plus 13x plus 15. That matches my original problem, so I know that this is my correct factorization. So this would be my answer, the factorization. This is just a check. This is just checking to see if I did the factorization right. Okay, our next problem we're going to look at is 3x squared minus 21x minus 24. So remember, the first rule of factoring is, do you have a GCF? So remember, you want to see if your A value multiplies into all three terms, B and C. So if I see 3 is a factor of 21 and 24, so I can divide 3 out by each one. And then I put 3 on the outside since I divided it out, and I'm left with x squared minus 7x minus 8. Okay, so now my A here is equal to 1. I do my x thing. I'm looking for factors of A times C, which is negative 8. It gives me negative 7. Factors of 8 are 1 and 8 and 2 and 4. I know I can get a 7 from 1 and 8. This needs to be negative. This is negative, so I'm going to make my negative 8 and negative 1. Positive 1. Sorry about that. Because negative 8 times 1 is negative 8, and negative 8 plus 1 is negative 7. So this factors into 3 times x minus 8, x plus 1. I do the math. X times x is x squared. X times positive 1 is plus x. Negative 8 times x is negative 8x. And then negative 8 times positive 1 is minus 8. So this is, I'm going to have the 3 on the outside. So this becomes 3 times x squared minus 7x minus 8. Distribute the 3 in. So I get 3x squared minus 21x minus 24. Alright, so that tells me that that's the original problem. And so this is my correct factorization. So this is my answer. Remember, this process here is just checking my work. This is just a check. Okay. Okay, our fourth example here is 15x squared plus 27x minus 6. Our first rule of factoring is there a GCF? Well, my A value is 15, and I know 15 doesn't factor into 27 or 6. And this is when you ask yourself, does factors of 15 multiply into 27 or 6? So my factors of 15 are 1 and 15 and 3 and 5. Well, I know that 3 is a factor of 27 and 6, so I can factor out the 3. So I'm going to do that by dividing everything by 3. Okay, so I'm going to divide each term by 3, and then I put that on the outside, and I get 15 divided by 3 is 5x squared, 27 divided by 3 is 9x, and then 6 divided by 3 is 2. Alright, so now I look at my new found trinomial. My A is not 1, so this is when I take the 5 and I slide it down to the 2, and I multiply. So I'm going to have 3 and x squared plus 9x minus 10. So now my A is 1, so I'm going to multiply, do my little x. I need something that multiplies to give me negative 10, but add to be positive 9. My factors of 10 are 1 and 10 and 2 and 5, so I know right away I can get a 9 by 1 and 10. So my factors are going to be 1 and 10. I need this to be negative 10 and this to be positive 9, so if I make the 1 negative, negative 1 times positive 10 gives me negative 10. Negative 1 plus 10 gives me positive 9. Alright, so that means that my factors become, bring the 3 down, x minus 1 times x plus 10. So since I multiplied by this 5 through, I have to come back and divide out the 5. So I'll put divide 1 by 5 and 10 by 5. Since I cannot reduce this fraction, it's where we need to do the bottoms up. We bring the 5x up there, and then this becomes x plus 2. So now we're going to FOIL out to check our work. 5x times x is 5x squared. 5x times 2 is plus 10x. Negative 1 times x is minus 1x, and then negative 1 times 2 is minus 2. So I get 3 times 5x squared. 10x minus 1 is 9x minus 2. Multiply the 3 through, I get 15x squared plus 27x minus 6. This matches my original problem, so I know that this right here is my correct factorization. And remember, this right here is just checking my work. I'm just checking the work to see, make sure I get it correct. Okay, so there's my multiplication. Alright, so here is a factorization problem again. Remember when we have two terms that we have a little different steps where first thing we ask is there a GCF? And I noticed that I have a 3 will go into 27, and they also both share an x. This has 2 and this has 1, so they share a 3 and an x, and a 3 and an x. So I'll put that on the outside. 3x squared divided by x, 3x, x left over, and then 27 divided by 3, x, and 9. So these all cancel. Okay, so that would be my multiply it back out to see if I'm correct. I have 3x squared minus 27x, so that's a check. So this is my correct factorization. Okay, so here's another example. I have two terms. So again, first question you ask yourself is, do they share a common factor? So there's not a common factor between 25x squared and 9. So since I have two terms here, the next question I ask myself is, do I have a difference of perfect squares, a difference of squares? So you ask yourself, is the first term a perfect square? Is the second term a perfect square? And is it being subtracted? So yes, the first term is a perfect square, the second term is a perfect square, and then I do have a subtraction. So this would be a difference of squares. And when we factor a difference of squares, this is when you set it up to two binomials. You take the square root of the first term, so the square root of 25x squared is 5x. The square root of, put that here, and then you take the square root of the second term, or the last term. Square root of 9 is 3, square root of 9 is 3, so then you make one a positive and one a negative. So let's multiply this out just to make sure. 5x times 5x is 25x squared. 5x times minus 3 is minus 15x. 3 times 5 is plus 15x, and then positive 3 times negative 3 is minus 9. These two cancel out, so I'm left with 25x squared minus 9. This matches my original problem, so I know that this is my answer. It's my correct answer here. And this here was just a check. Okay. Okay, class, make sure you bring any questions you have on factoring to the class tomorrow. Keep in mind that we are having a test over quadratics on Friday, and we will have an open response on Thursday. Have a good night, and I'll see you tomorrow.